Good day, grade 11s. Today we are going to look at a number pattern which we call a quadratic number pattern. Okay. Before we carry on, I just want us to consider this number pattern that's written in black. Okay, 2, 5, 10, 17, and 26. I just want us to explore it to check what type it is. Okay, we'll start. Let's explore it. Let's start by looking if it is geometric. If it is geometric, it would need to have the same number that we multiply by throughout. So now from 2 to 5, I would need to multiply by 2.5. And then from 5 to 10, I would need to multiply by 2. Then already you can see that these two numbers are not the same. 2.5 and 2 are not the same. Therefore, it is not geometric. So we throw that option away. Okay, and then let's check if it is linear. Remember, we said linear number pattern will have the same number that is added or subtracted throughout. So now if you look from 2 to 5, we add 3. And then 5 to 10, we add 5. And then 10 to 17, we add 7. Already you can see that the difference is not constant. So that means it is not linear. This number pattern is not linear. Okay, so what type of a number pattern is it then if it is not geometric and it is not linear? If you look at this, the numbers 3, 5, 7, and 9, looks like they form a pattern, a linear number pattern. Why do I say it is a linear number pattern? If you check from 3 to 5, it's 2. I need 2. From 5 to 7, I also need 2. And then from 7 to 9, I also need 2. So this number pattern, which is not geometric and it is not linear, produces a linear pattern. So if it produces a linear pattern, then we call it a quadratic number pattern. So this number pattern is not geometric, it is not linear on itself, but the difference that you get out of it is a linear number pattern. So if a case like that happens, then the number pattern that you have, we say it is quadratic. Okay, so this is what I've written here. 2, 5, 10, and 17 is a quadratic number pattern. Now, what is a quadratic number pattern? This definition you need to know because in an exam you may be asked. That's why I've written here definition is examinable. Right, so a quadratic number pattern is a pattern that has a second difference which is constant. So this is your first difference, the 3, 5, 7, 9. That would be your first difference. Then to determine if this is linear, you needed to do another difference. So this other difference, we say it's the second difference. So if it has a second difference that is constant, if these numbers are the same throughout, then the number pattern that you have is linear. The number pattern that you have is quadratic. Okay, so since it's quadratic, it has a general equation. Tn is equals to an squared plus bn plus c, where n is the position of the term and a, b, c are values that need to be calculated. So how do we calculate those values a, b, and c? So I've written the number pattern again. So the first thing that you do after you've been given the number pattern, you find the first difference. Okay, so my first difference is 3, 5, 7, 9. You find the first difference. Okay, then after here, as you can see, it's not linear because the first difference is not constant. Then you find the second difference. So second difference is the 2 that we have calculated here. And now because it says 2, 2, 2, it means this is quadratic. So if it is quadratic, then it means we can find a, b, and c. So how do we find the a, b, and c? We use the first number in each row. There are 3 rows, there are 3 unknowns. Okay, so we use these 3 numbers to find a, b, and c. So the first one to be used is the 2 at the bottom. So we start at the bottom and then we go up. Please don't forget, we start at the bottom and we go up. So the first one that we will find is A, and we use this 2 to find A. So all the time, these values are going to be, the values are going to be equated to 2A, 3A plus B, and A plus B plus C. When we have time, when we go back to school, I'm going to show you why these equations are. But now it's going to be too complicated for me to try and do it over here. So just accept them as they are. I will show you why these equations are. Okay, so we have 2A, which is equals to 2, and then 3A plus B is equals to 3, and then A plus B plus C is equals to the first number. So every time we use those the first three numbers, well, the first number in each row, and then we equate each of them to these equations. Okay, so and then you solve these equations. So we start here. 2A is equals to 2, so A is going to be 1. Then you substitute that A into this equation, the second equation. So 3 times 1 plus B is equals to 3, which gives you B, which is equals to 0. Then you substitute A and B into the third equation, A, B, C. Then you substitute 1 plus 0 plus C is equals to 2, and then 1 goes to the other side, so C becomes 1. Then you substitute into the general equation. So Tn is equals to, in the place of A, you put 1, so it's 1n squared plus 0n plus 1. Then don't forget to tidy it up. And when you tidy it up, no brackets and no zeros, so please tidy it up. So 1n squared will become n squared, 0, because 0 times n is 0, so it disappears, and then plus 1, which gives you this. Okay, so the general equation, so this is an equation that can be used to find any term that lies in this or that belongs to this number pattern. So you can use that as n squared plus 1. And as you can see, this one J is if you this on position number 2, so position number 2 is, n is equals to 2, so n squared, 2 squared is 4 plus 1 is 5, so it works. Here n is 3, so 3 squared is 9, 9 plus 1 is 10, so the equation works. So yeah, the equation is true. So you can also check before you move on if it gives you the numbers that are already on the sequence. Okay, so you can also be asked to then find term number 15. So instead of listing the terms 15 times, you can just substitute now into the equation. So T15, in the place of n I have 15, so I can, in the place of n in a bracket, I'm going to have now 15 squared is 225 plus 1, which will give me 226. Okay, I hope that is clear. Okay, let's look at the second example. All right, so now I've just written, we are going to just work on it like you would do in a test or a classwork. So 6, 17, 34, 57. So the first thing, you find your first difference. So it's 11, 17, and 23. Then as you can see, it's not linear. It's not constant. All right. Now explore and find the second difference. Second difference is 6 for this one, and then again it is 6 here. Remember, it is 23 minus 17, you get 6, and then 17 minus 6, you get that. Minus 11, you get that. Now as you can see, it's 6, 6. Then you take your pencil, you say this number is equals to 2. So it will be the same. This will be the same all the time. It is 2a, and then it is 3a plus b, and then it is a plus b plus c. All the time we use the same thing. What will be different is these numbers, but we always use the first number in each row, not the last one, the first number in each row. So that's what I did. So we solve 2a plus 2a is equals to 6, therefore a is equals to 3. We divide by 2, Then you substitute that a into the second equation. So it's 3 times 3 plus b is equals to 11. So b is equals to 2. And then 3 plus 2 plus c is equals to 6, which gives us c, which is equals to 1. Okay, so this is the general equation. You don't have to write it. I wrote it so that you can see the substitution. Okay, so when we give you a test, we mark A, we mark B, we mark C, and then we mark the substitution, the final equation, 3n squared plus 2n plus 1. Right, and then a second equation, a question that can be asked is for you to find T68. So that's what you do. Okay, T68, substitute for n, which is 68. And then B, which term is equals to 30,201. So that means we are looking for n. So like we did yesterday, you substitute into your equation 30,000 in the place of Tn, that's what you put, and then you write your equation on the right hand side. Then you work backwards to find n. So that means we take this, because this is quadratic, it means it has to be equals to 0. So we take this to the other side, and then we have this quadratic equation, 3n squared plus 2n minus 1, which you can then solve by either factorizing or using the quadratic formula. You know the quadratic formula. So quadratic formula, you'll get a mark for substitution, which is equal to n. Don't just leave this blank. You must say what you are solving for. So n is equals to substitution, which gives you two values. It gives you 100 and it gives you negative 302 over 3. Now we have to disqualify this one because position cannot be negative. And then you answer your question, because the question was which term is, and then you have to say it is the 100th term. All right, so basically that's all there is to it, to number patterns. Generally, this is the question that you would get in a test. There really isn't anything hidden. All right, please do exercise 2, number 1, 2, and 3. Thank you.